Yeah, so you've probably heard a lot of talk about the 64-bit commitment and story coming out of Microsoft. And what exactly does this mean? What are we talking about? First of all, to kind of highlight why 64-bit is important and interesting, you have to look at the roadmap of computing and
Music is hard. Hey, you mute it? Sorry, sorry to interrupt you. But since we don't edit on Channel 9, people are going to see that. Continue, please.
yeah. So kind of what's the history, the background, the roadmap of going to 64-bit. So there's a couple of things that people need to know and be thinking about. So one of these things is that computing obviously goes through this evolution. We came from 8-bit computers at one point in the not too distant past to 16-bit to 32-bit, and this is just the next obvious step in this evolution. So what does going to 64-bit give you? The main thing that it gives you, in of itself, is that it gives you a larger address space. And in some ways that seems almost mundane, right? Now you have more memory. But in other ways, this actually brings about a whole new way to think about problems and introduces new things that you never even considered doing in the past. It makes it something that you may consider doing. And that's the type of thing that these technological revolutions tend to encourage, that they bring about new ways of thinking about problems, because things that in the past you just wouldn't even think about doing, now all of a sudden you think is realistic. And I think one of the big things that we'll see going forward is two spaces that I think are very interesting, one of which is data mining. So nowadays with the internet, as you can imagine, there's just a lot of data that's sitting out there. And in the 10 years or so that the web's been popular, we've generated as much data as has existed in the past up to this point. And the question is now, how do you effectively mine this data? How do you get useful information out of this data? And with 64-bit, you can now take this data and actually have it, if you had a machine with this much memory, and go through and now mine it and do interesting things over it. Mm-hmm. And the other thing that's very interesting, in my opinion at least, is also media. So now we have, obviously, streaming video, and different digital video recorders are becoming more popular, and MP3 players are becoming more popular, and that sort of thing. And so the amount of media that you want to take a look at is also growing. And this is also another space where doing interesting things with media and editing it and aggregating it will also now require more memory. And I think this is a space where we've only really begun thinking in the past couple years, what do you do with video? What do you do with audio? And I won't even presume to say what we should be doing with it, but I think, 10 years down the road or 5 years down the road, we're going to look at where we're at today in this 32-bit world and think, how could you live in that world? In kind of the same way that you think today, how could you live without the web? I think it'll be a very similar effect, and I think this will be sparked because of the 64-bit evolution/revolution that we're just embarking in now.
Fantastic. Now, for developers out there, what does this mean in terms of their existing code? So you have the 16-bit applications, and they have to migrate to 32-bit. Now you have to migrate to 64-bit to get all the benefits. You don't have to migrate anything, though, correct?
Right. So it turns out that there is, a couple of interesting stories here. So one of the most interesting things is if you write manage code today, you can, you write verifiable C++ or you write C# or Visual Basic.NET. You can now take that application, the exact same binary, so not even source code compatible, but actually take the .exe file, and you can move that to now a 64-bit machine, and it'll run in the 64-bit CLR. And that happens, no source code change. Again, like I said, it's the exact same binary. Wow. No changes there. And I think that's pretty incredible that you can now go ahead and move from 32 to 64-bit. And one of the cool things is it allows you to do things like have that exe sitting on a server and or ship it out to machines. And it doesn't matter which platform they're running. It'll go ahead and run on that platform. If you're doing native code, you will have to go ahead and recompile the application, with a 64-bit compiler for it to run as a 64-bit exe on the 64-bit machine. One of the things we've taken, we've done tons of work on the development team, and throughout Microsoft, is making sure that the actual migration process is as simple as possible. We've looked at various different trade-offs. For example, deciding what should the size of long be. should long be 64-bit as it is in the Unix world, or should it be a different size? And after careful analysis, we figured that 32-bit would actually be the most logical way and the best progression to making 32-bit applications easily migrate to 64-bit. And so we went ahead and did that. And as well, one of the other things that we've done is we have this great Windows on Windows execution layer. So you can take your 32-bit application, XE, and run it on your 64-bit operating system, and it should just work. So you can take your favorite application that you bought at your store, install 64-bit Windows, and you can still run this 32-bit application right on top of it. And this works pretty much across the board. The only limitations that we currently have really at the moment are kind of at the corners and in some cases that most people probably don't care about. In particular, kernel mode applications, those will still have to be 64-bit when you run them on a 64-bit OS. There isn't 32-bit support there for kernel mode applications. If you have 16-bit applications, you'll have to move those to at least 32 bits. So those are the types of things that you may end up with problems, but for 99.9% of applications out there, and that's not a scientific number, but you take 32-bit application, run it on your 64-bit.
Absolutely.
And in fact, there's also another cool thing about going to 64-bit, is if you have an application, a 32-bit application, which is sensitive to memory, so it needs a lot of memory. On 32-bit Windows, what you can do is you can say, make this application large address aware, and I want it to use 3 gigabytes. And so what happens then is now your application can use up to 3 gigabytes of address space, and the OS gets the remaining 1 gigabyte of the total 4 gigabytes. But if you go ahead now and move to 64-bit, your application now actually, if it's large address aware, can access the full 4 gigabyte 32-bit address space. So actually, even by taking your standard 32-bit application and just running it on 64-bit Windows, you can actually now get an extra gigabyte of address space. And that install comes for free.
Excellent. Now, do you get any sort of perf improvements with going 32-bit application on 64-bit platform?
That's a good question. A lot of people, hear 32-bit, 64-bit, and they think 64-bit, twice as many bits, you must get twice as good performance. And that obviously, that just isn't the case. As it turns out, it does depend a bit on the application, how much performance wins you see. What we tend to see is that for a lot of applications, you do get a performance win when you go to 64-bit. Although it's typically not because it's 64-bit necessarily. But if you look at the 64-bit architectures that we support with Windows, Itanium and x64, and I should be clear, x64 is both AMD 64 and Intel's EM64T. We put those both under the moniker x64. For us, if you see something that's x64, it runs on either platform. The main win you get when you go to 64-bit actually tends to be because of the architectural differences of going to 64-bit. So, Itanium, for example, has great floating point performance and tons of registers. And so you tend to see very good performance with Itanium, and it has a great scaling story with good memory bandwidth. And on x64, you have more of what made x86 great. So you have more. They added more registers, for both general purpose use and for floating point use. And one of the other things we were able to do, since we're bringing up a whole new 64-bit architecture, we were able to now optimize the calling convention. So the calling convention on x64, we went again through a lot of effort to tune it so that we think it's the best calling convention for the platform, and we're able to get performance wins there. So on average, what you'll probably see is 10 to 20% improvement for applications, but for a given application, it could potentially be slower. And the reason why it could potentially be slower is because when you go to 64-bit, your pointers get bigger, right? Because now all of a sudden you have a 64-bit address space instead of a 32-bit address space. Your pointers are now 64-bit. This can affect your working set, because now if you end up storing lots of pointers in your data, your working set can potentially become larger because your pointers are larger. And this ends up meaning that you end up touching more cache lines, you end up touching more pages, you end up using more TLB entries. And this can hurt performance. Another potential place where you could maybe lose some performance is also the instructions tend to be larger. So if you recompile an application with 64-bit, what you'll tend to see is the exe or DLL that you built is going to be larger than the equivalent 32-bit application. So some of your instruction memory hierarchy issues can creep up there as well. And so these are two factors that can potentially cause your application to get slower. In general, if you look over a wide spectrum of applications, doing with different types of workloads and characteristics, we tend to see that 64-bit applications are 10 to 20% faster. But again, for any given application, you could actually see that 32-bit is faster. There is also one other big place where 64-bit will fly compared to 32-bit, and that's actually where you have to use more than 2 or 3 or 4 gigabytes of memory. Because on 64-bit, you can now put that all into RAM, versus on 32-bit, you have to put together some mechanism for effectively paging this data back out to disk. And as you can imagine, going to disk is a magnitude slower than accessing data through RAM. So that's another place where you have large data sets. Having a 64-bit machine, can literally result in an application that's 2, 3, 4, 5 times faster.
That's excellent.